Hello everyone. So today we are going to discuss about electromagnetism. Electromagnetism is one of the largest field in physics. Okay, so electromagnetism can be further divided into two subfields. One is electrostatics, another is electrodynamics. So what are these? These are differentiated by these last terms, statics and dynamics. So it can be defined as a field which studies charge at rest, statics rest, and this field electrodynamics studies charge at motion, in motion. Now the defining factor, the new term is charge. So what are charge? It is an intrinsic property. Okay, it is an intrinsic property of matter. Now, what do we mean by intrinsic? Intrinsic means something which is very fundamental and it just exists in matter and we cannot define it. Another example of intrinsic property is mass for matter. Okay, so let's compare charge and mass. The main difference between charge and mass is that mass is dependent on velocity. That mass is given by root over 1 minus v square by c square. Okay, this term is called Lorentz factor. Now as the velocity of the particle goes closer to the velocity of light, the mass of the particle will increase. That means moving particle has higher mass as compared to a particle, the same particle at rest. Okay, but charge is independent of velocity. Now charges can be of two types, positive and negative, and they can also take zero values. Okay, and the unit of charge is coulomb. This is the SI unit of charge, and symbol we use to represent charge is Q. Now there is one very basic property of charge which is called fundamental law of electrostatics. Fundamental law of electrostatics, which we already know that like charges repel and unlike charges attract. Now let's understand the static electricity with the help of an example. Okay, so here if we take a glass rod, this is a glass rod, and this is a silk cloth. Okay, now if we take a glass rod and rub it with a silk cloth, there will be transfer of electron from the glass rod to the silk cloth. So as a result of which there will be deficiency of electron on the glass rod, as a resulting in positively charged glass rod. On the other hand, the silk cloth will be negatively charged. Okay, as a result of which static electricity will be developed in both the objects, and which can attract small pieces of paper. Okay, and why it is so? Because because of transfer of electron, and this electron has negative charge. One electron is equal to minus 1.602 into 10 to the power minus 19 coulomb. Now this charge carried by one electron is known as fundamental charge. Okay, the charge carried by one electron is known as fundamental charge. Now let's understand the fundamental law of electrostatics, that like charges repel and unlike charges attract. Now, if we rub a glass rod with a silk cloth, we are going to get positively charged glass rod. On the other hand, if we rub a plastic rod with an woolen cloth, okay, woolen cloth, then there will be transfer of electron from the woolen cloth to the plastic rod. So as a result of which plastic rod will be negatively charged. So now if we bring two glass rod, positively charged glass rod closer, they will repel each other, as we can see in case A. This is also positively charged, this is also positively charged, so they are repelling each other. Now if we bring a plastic rod closer to another plastic rod, then also they are going to repel, and this is quite obvious in case B. Now because like charges repel, now as we have already mentioned that unlike charges attract. Now if we take a positively charged glass rod and negatively charged plastic rod, then they are going to attract each other, okay, and this is because unlike charges attract. So this is how we can experimentally prove the fundamental law of electrostatics, that is like charges repel and unlike charges attract. Okay, conservation of charge. So what it says that first of all, charge can neither be created nor be destroyed. But can only be transferred. Okay, and the second statement for conservation of charge is that the total charge on an isolated system, okay, isolated, this word is important, isolated system is constant. So what do you mean by isolated? Isolated means lonely, alone, that it is not surrounded by any other system, okay. So what do we mean by this? If we consider an isolated system comprising of three particles, okay, one carrying 2 coulomb, positive 2 coulomb, one carrying positive 3 coulomb, one carrying negative 1 coulomb. So the net charge carried by the system will be 3 plus 2 5 minus 1 4 coulomb, okay. Now if we consider the same system, but this time the particle has exchanged their charges. So what is going to happen now? Charges means they have exchanged electron with each other. Now let's say one charge is carrying charge 2 coulomb, another charge is carrying charge 2 coulomb. Now we want to find what is the amount of charge carried by the third particle, okay, and that charge will be, because the total charge is conserved, therefore let's say this charge is Q3, therefore total charge will be plus 2 coulomb plus 2 coulomb plus Q3 will be equal to 4 coulomb, which implies that Q3 is 0 coulomb. Okay, which means if the system is isolated, inside the system there can be changes, but as a whole the net charge will be conserved. Okay, and now charge can neither be created nor be destroyed, but only be transferred. Okay, now let's talk about quantization of charge. So what does it mean by quantization? Quantization means in 1p, which means you cannot have fraction. Okay, you cannot have fraction of charge, but fraction of what? Fraction of fundamental charge. So what is fundamental charge? Okay, fundamental charge is a charge carried by one electron, which is equal to 1.602 into 10 to the power minus 19 coulomb. And the quantization of charge says that in nature in nature charge can only exist in integral multiple of fundamental charge. Okay, which means charge that exists in nature is equal to either plus integral multiple of electron charge of electron or negative charge of integral multiple of charge of electron. Okay, so this means the quantization of charge. So which means that in nature charge can exist only in the form plus 1e, plus 2e, plus 3e, and so on, or minus 1e, minus 2e, minus 3e, or in 0. Okay, 0 coulomb. This is the only way in which charge can exist in nature independently. Independent word is very important because electron can further be classified into 3 quarks. Okay, 3 quarks which have fraction of charge. 1/3 of electron, 2/3 of electric charge. Okay, but they cannot exist in nature independently. They always exist in nature in group of 3. Okay, which is why electric charge is the minimum charge that is available in nature independently. Okay, so that's what is meant by quantization of charge. Now let's consider an example from NCERT book. The question is, how much positive or negative charge is there in a cup of water, given that 1 cup of water is 250 gram of water and molecular mass of water is 18 gram. Now, as we all know that if we divide the total mass with the molecular mass, we are going to get the number of moles present in a cup of water. So the number of moles in a cup of water will be equal to 250 by 18 gram. Okay, now we know that 1 mole of any substance contains Avogadro's number of molecules. Avogadro's number is given by 6.02 into 10 to the power 23. So therefore total number of molecules in 1 cup of water will be equal to Avogadro's number multiplied by number of moles. So this will give total number of molecules as 8.36 into 10 to the power 24. Now, as we all know, one water molecule contains 2 electrons from 2 protons from the hydrogen atom and 8 protons from the oxygen atom, total 10 protons, which means or 10 electrons as well. Therefore total number of protons or electrons in 1 cup of water will be equal to total number of molecules multiplied by total number of protons and electrons in 1 molecule. Okay, Therefore, if we want to calculate the total charge contained in a cup of water, will be equal to total number of protons or electrons in a cup of water into electric charge, which is equal to 1.6 into 10 to the power minus 19 coulomb, which will give us the result 1.33 into 10 to the power 7 coulomb. Okay, so therefore the total charge in a cup of water will be equal to 1.33 into 10 to the power 7 coulomb. That's it for today. Please like, share and subscribe to my channel. Thank you.